So you have my screen at the
Yes.
moment? Okay, so I have uploaded an image which is the same as this one, but each project here has morphs on it, which are ready to play with. And what I was thinking was going through these different projects and giving them each 5 minutes and rebuilding the morphs you can see in your image, whether you have it open or not, doesn't matter, to see how they're done. And after the talk, if you're interested, you can take the image and have everything ready, more or less. So 5 minutes times, I think 9 is 45. Should be around 45 minutes if I can keep this. So is it okay? So I start. Principles. So muO is a very big system for music, and I'm not going to introduce muO here. I just wanted to show a very specific type of morph that I use everywhere, and that shows also the kind of flow I get when I do music with Squeak, and that's a very morphic thing. So I think it's a way to show how Morphic works. So a zoomable field, here is one, is just a window on a plane with its specific coordinate system. So if I make a grid up here, I can scroll it. Okay. And I can stretch it this way. It's like a gesture where I press shift and I drag, and this changes the scale. So on this Canva, this is the abstract class. We have two types of specific morphs. The floating morphs, like this point, once dropped on the Canva, will move with it. And when scaled, the morph itself doesn't scale, it just stays where it is. And we have the extended version, this one, which scales with the Canva. So this is the basics for many morphs that can be made.
Have you only done that on the Squeak or also on Quiz where you have vector morphs?
No, it's all Squeak. This started like 20 years ago. So it's a long thing. This one is a floating morph, so it doesn't scale. Its corner stays where it was put in the remote coordinate system. So this one is a post-it, actually. I can take, so for example, if I take a small bit of screen, that's fun. I can put it in the post-it and I can put any comment. So what you can see here also is that once I have put a morph on the Canva, it remembers its place. So if I can take it out and it will go back where it was taken. There is an option here to make it draggable. And in that case, you can drag it around. And when you remove that option, it will again remember where it came from. So when you scale the field, you see these three objects behave differently because this one is located at one single point. This one has this corner located at a single point, but doesn't change its extent. And this one is scales completely with the Canva. And the other thing we have is a very bare organization with no UI at first, but deep menus. And the menus in muO can be destructured. That's something I took from KeyKit by Tim Thompson. So whenever you have a menu, like this is the main muO menu that you get when yellow clicking in the background. You can take anything directly by dragging and clicking, and you can make buttons from any item just by clicking, by right clicking, sorry. So in that case here, let's say I have this this point, for example. I just destructure its menu. I take the show allow item. So this works as expected. And these morphs, which are ordinary morph menu items, they have a specific layout. They will keep. Oops, sorry, this is a mistake. Okay, I will copy the stuff because I cannot grab it here. Okay. You see that the buttons, they stay close to the corner where they were put. That's a specific layout that I call screen layout, which allows to actually build the GUI you want to use for your tool. At the same time, you are building the tool. So this is a kind of the abstract way. Now I can show you an example of actual editor made on this system. That's an envelope editor. So I will reduce this, put it there. Here for the envelope, the floating morph is this handle, for example. This is a floating morph. I can give it an interactive interpolation. And this is another floating morph. So here we have an envelope editor, which is made of floating morphs for the handles and for the control of the shape. So that's the basic introduction to what is a zoomable field. Now I will show you a musical phrase editor. Is my accent correct? Because I think I'm speaking very, very badly English. So do you understand me?
Perfectly clear.
Yeah, okay.
Great. Not like Stéphane Rollandin, really clear.
C'est bon.
Ça va. Merci. Okay, so here I make a musical phrase, just the E minor mode, and I display it as its own editor. So the stretching thing is this. I can stretch, I can zoom a note if I want. There is a specific grid here, vertical, because we use a rhythmic canvas in muO. The rhythm is a first-class musical object and has its own structure. So this is that's what happened here. Actually, I made first a phrase, mod E minor as musical phrase, and when I asked it to be displayed, I provided it with a 4/4 time signature, and that's the time signature we can see here. So we have the grid of the zoomable field, which is still there. Here I'm making the grid appear, and there's different level of resolution. Now, you can compose music directly in this kind of tool. For example, there's different ways to display the music. What I've done here is taken the contextual menu, part of it, the part here, display items. I detached the submenu. And now, if I want a piano roll, here I have a view as a piano roll. And of course, each menu is linked to its original morph. Here, for example, is a sheet music display. This is exactly the same morph, but the representation is different. So here, these rectangles in the binaural are just graphics. They're part of the plotting abilities, the plotting methods that are implemented in the zoomable field, which is mostly a plotting Canva. If I want to show you an extended morph, an extended floating morph, I can make an handle here. And this rectangle here is something that gives me an handle to move the note. I can actually give handles to all notes this way. And I can also decide that these notes will have legato handles, which means that the notes stay legato. When I move one, the other ones rescales accordingly so that the musical line stays legato. Now, let's suppose, I think, what did I say I should do? Yeah. So this morph is an extended morph. It will scale with the display. So this here is for amplitude. And now I will show you how you can make a very fast, a little system to play with this thing, which was initially just the mode E minor. In the operation menu, we have many ways to tweak the music there. And for example, the articulation is here, legato. So this is just a button. I will just put it here. I take another articulation, let's say staccato. I'll take here. And now I can change. And of course, if I copy the morph, I have two different phrases. Let's add another. No, operation. In basics, we have reverse. And in tuning, no, transposition, we have flip. So here I can flip, which means transpose in a mirror effect the notes. But I'm not here to talk about music this evening. It's more the idea that I have made in just a few clicks, and by destructuring the menus, which are huge and with a lot of options, just by taking the ones which are the items I was interested in, I made a specific tool which can be duplicated. With various effects that are a bit complex to explain here. And then I can make bits of music with it and use them elsewhere. And the screen layout that I showed, the fact that this button move with the resizing of the morph, make them always available. So it's kind of a simple way to get a fast UI for what you're doing, for the task at hand, which in that case was playing with a simple musical phrase of a few notes. Okay, so that's the second part. Now, yeah.
Before we move to the next, there's a few questions from Dave. So I'm gonna go back, and so the first question is, why not one morph with a switch? And is the window itself a morph that you could nest? Yeah, it was for the, especially for the initial.
Yeah. I will show you. Actually, his discussion is a bit in advance. I will show that here.
Okay. Well, if it's later, then we can just leave the question open.
Yeah. This part here was a way to show the versatility of the representation, the grid. I have here, if I did not lose it. Okay, this is a MIDI file of music from Bach, and so this is the way we can read a MIDI file. So this is basically the same tool we've just seen. So we can zoom in at any level. You can grab, change the music here if you want. Change the volume. Each note is available here. And I wanted to show how you can, from a tool like this one, which is a musical phrase editor, get another tool which gives you another point of view on the structure of what we have here. So this has been built as from MIDI. So the different colors correspond to different MIDI channels. And because this information is structured, I can edit here, edit it in a different way as a composite mix, which is a kind of the equivalent of a digital workstation where you have elements that compose the music. And so what we have here is again a scalable field, but this one is organized in rows, and each row contains one track of the MIDI file, plus the rhythmic track. And inside, so this here you had a note, one handle for a note. The equivalent is here. You can have an handle for one element. This one here. I can move it, and I can edit it. And if I edit the element, another zoomable field appeared inside the zoomable field. I can change this note, change its volume, move it, then exit, and the change has been reflected here. And so this will bring me to the answer to the question, the composition. This one is where it gets more original. So in a new menu, I can take what I called a projection. So I will not explain what projection is, but it's a method I implemented to generate, because I do not have a formal education in music. I don't know at all how to write music. I don't know how to read music or to play music. So I just made up my own toys to generate music. And this one, which is based again on the zoomable field, is based on the idea of projection. So projection is that I take an event here, for example, a note C. So this is a C note, which is indicated by this triangle here. And this note I can put in a 2D location. And then I take a projector, which is a way to arrange linear segments, which are in fact the timeline itself. So this projector here is like a bouncing billiard table. And here we have, let's say 5. We have 5 seconds of time, which are bouncing inside the circle. And each time the event gets an opportunity to be projected on the timeline itself, it will generate a note. And the exact note that will be generated depends on the direction, length, and the side of the event with respect to the line itself. So this is a bit abstract, but the point is,
but brilliant.
This we can get here. Where is it? This one. What is it? I'm getting so shy that I'm losing my.
Well, I'm getting really excited. It's really what you're doing here. It's
get a view. That's it. The thing is, these menus are so huge that I have to remember where things are. So here I'm interested in this projector, and I take a double view, combo view, which will display both. Okay, so this is I have to actually install it inside. Okay, so here you have the answer to your question. This thing here has many several zoomable fields. The first one, which is here, and these ones they are linked together. The upper one here represents the projections we get here once the timeline has been straightened up. So we can see how it unfolds, in fact. And the second one here is the effect of a kind of setting which is very complex to set up, but this is the default one, which transforms, maps these projections into a musical phrase. Musical phrase, which is a very, very like a raw material for the following. All notes there are not in tune. There is no mode, there's no rhythm. It's just the raw projection thing. And from there, I can get something which is called a phrase generator. And this thing here, this phrase generator, is an extending above. Oh, okay, you want to stay there, no problem. So I will take now a phrase editor, the same ones we have seen before when we made the melodic line. I will give it some rhythmic cadma. Let's say 8/8. Okay. I will give it a musical mode. Let's say mixolydian. Yeah. Okay. So this generator, I can put it here and ask it to take where is it? Constraints to lock on bars. We have bars because we have defined a rhythmic cadma. So now this, what happens here is that the raw music which has been synthesized here is appearing inside the phrase editor. And I can give it phrasings to make it actually musical. So first thing, we can add some quantization. This thing filter here, broad, will keep only the notes which are broadly in proper places within the musical cadma. So we get already something which is more sparse than the raw material which is here. And then we will give it some way to sound pleasant. That is, we'll tune it simply. So we can decide that the notes will get in tune on the mode or on the scale. So here the mode. So this time, the notes which are here are actually musical, and they are built from this raw material here, which is again built from the projection here, and everything is linked. So I can sculpt a melodic line either by moving here.
We can't wait until you switch on the sound.
Well, it's very,
if you move
It's
I'm
very like
sorry, if you move one of the notes, does the star change as well? Is it
no, it's one direction. It's on because
Okay.
it's actually lossy. And also it's method of a generative method. There is no way to get from this part to this one or this one to this one. This is a mapping from here to here, so you can define any arbitrary mapping. And I do not see interest of reverse mappings, although you could if you want.
Thank you.
And yeah, I wanted to show you because I don't want to go into the musical part because that would be a rabbit hole. I wanted to show you how the workflow is structured. So this here as a is even more complex than it seems, because as I told you, the timeline here is generated from the bouncing within this circle, but in fact each segment can be the basis for a prototype for a way for this segment to become something else. And one prototype is simply the tilted segment. So this makes me able to tilt the other setting. So I take the setting away from the menu here. And now this time, the segments that are there, I can make them tilt. And I can also change their size. And so all of this together makes me able to sculpt the music. And so someone said that he was excited to hear the sound, but most likely it will be just awful because the tweaking of these systems to get something which is actually useful in a musical context is the fun of it. But it's really not straightforward. It's not like an easy way to generate very fast something which is nice. It's more
you mean not like a theremin where the interactiveness itself allows you to find the note.
I'm afraid that if I want to answer this question, I will really drift away from what I want to talk to this evening, because it's the core of the feeling and the intuition I have for music. But I will be very happy to talk about that in another context if it's possible.
Well,
now the thing here is that this is a tool that I can duplicate. That's That's what I wanted to show. All controls here coming from the menus are independent. So I just made, if for some reason, if by chance this was an actual way to get something interesting at this level here, then I have this tool and I can make another one. I can duplicate. So if I take another phrase generator, I put it here, and I have a second one. So now I can play this part is here. And this part is here. And this is a two-part piece. Okay, so I'm very tempted to talk more about the musical part. That this is not the topic for this evening. The idea is to show how these different morphs have been combined to make this, and I can now kill them if I want. They are in fact referenced in these boxes because the boxes can give you back the tools that make them. And of course, I'm actually the zoom thing is a bit annoying because I cannot have access here. Okay, I'm moving this finger away. Yeah, I can also copy this, of course. And if I copy this, I copy everything. So now we have, for example, here. Ah, that's the good one. Okay, this and this one, which is not the same. So I can, that's actually how I make music by some kind of music by segmenting it in themes that I can trick individually and that come together both with their representation and their generative tools, and everything is interactive. I didn't code anything there. I didn't have to type anything to get music. Okay, so that's the reactivity composition thing. So maybe I can take questions related to music, because we will. No, sorry, not music. It's not a good idea. I was thinking about going to the. This can move. Sorry, I'm just discovering Zoom. I'm not used at all to Zoom, and there was something that was preventing me from doing things. Okay, so I wanted to show you another take on this these control things, and this is yet another kind of worm. It's another part of the system I made, which is called LambdaMessageSend, which gives some functional abilities to message sends, actually. So here I create a send function, which is this object here. A lambda x is a lambda slot, and I just say x send. This is a lambda message send, and I specialize this as an end function, which makes it able to be displayed. This function, so this again is a zoomable field, a plotter, just a mathematical plotter in that case. And I can give generic handles, what I call handles, to the function, which is the generic way to change the scale of any function. You just multiply its amplitude by something and add some point to it. So here I've taken my sign. I can handle it actually, like something very physical. And if I clone it here, I have a second sign. I clone the first function. So I will color the first function, let's say in red, and color the second function, let's say in blue. Okay. So I can move the first function because I have its handles. I could add handles to the second function, but what I want to do now, in fact, is add the two functions because they are lambdas. So I add a third function, which is f1 plus f2. Why didn't it work? I don't know. F1, because I did cancel maybe. Okay, this is the third function. So I will make it a green. So here the green function is the sum of the red one and the blue one. Since I can move the red one, I can in fact move the sum of the two other functions. If I duplicate this thing, everything is autonomous. I can remove the third function. I remove the first function, but I keep the controls. And I remove the second one, and I keep the controls. So this was just a way No, bad, bad one. I remove F2 and I remove F1, but I keep the controls. So what I did here is, this is just a step to get here a function, a curve that I can play with, and which is a little more interesting than the initial ones. And this, I like it because I like curves, but also can be used. So again, I take a phrase editor. And from this editor, get a melodic curve. I get yet another tool here that allows me to create notes inside the rhythmic Canva. So let's say again at the Canva. This is already 8.8. Constraint, local. Okay. We'll give it a musical mode. Measure. Okay. So now we have this function here. Can be used to create music again. And the editor is also inside. And I can also make at the end here of this menu, we have the menu of the function editor with the F3 function is still available, and I can get its handles, which are the handles that are here, are now here. And inside the phrase editor, I have a function editor, which itself generates notes. And it can be fun to use a display which is close to the usual music display, because now you can see how this works. So again, editor inside editor. And that's it for this one. And now next step, sound. So here is some sound. If I edit it, I have a variation, a specialization of the function editor that we just saw, which is tweaked to represent waveforms. So when we zoom in, we can see the actual sound at the scale of the individual sample, if you want, because everything can be stretched. And which is represented as a function. And the editor is specialized by the fact that when I stretch, it kept getting centered here, exactly as you would expect if you want to see a waveform. And when the waveform cannot be clearly separated because it's fluctuating too fast, then at this point, another display appears, which is just the envelope, upper and lower envelope of the sound. And now we can make also show how different zoomable fields can be composed by making a spectrum plot appear, which is itself a zoomable field. And this menu here, now, sometimes it's a bit tricky to get up. Okay, the menu. So here we have the line, the green, the greenish line, which is here at the left, is the point where the spectrum is taken. So I can slide it here. So this slider here is also just a button. I can destructure it and put it here if I want. And so I have two now. This is the size, the number of samples taken to do the FFT. So here we have an editor inside an editor, and we can have a display on top of it, the spectrogram, which is here. So I can both move the whole display around and see the spectrum part as it is swept by this band here, or I can swept the band itself. I can change the top bin that I want to see. This allows us to see the actual notes here of the sound with the harmonics. We can tweak the color of the spectrogram if we want to have it more or less obvious. Can make it. So this tool here is a very primitive but quite useful sound editor. In fact, at least for display, not so much for generation, but. And this is all something that can be tweaked. So if what I'm interested in is just this part here, and I want to be able to change just the luminosity, I can put this slider here. If I want to tweak to turn off the spectrogram, I put this here. Then I get rid of this, and this single object here has its own toggles now. And that's it for this part. So this is the sound. And here at this point, I am done with the musical examples, and I can show you how the editors themselves are used in other components in muO. For example, if I want to request to the user of some software some notes of music, I can use this idiom here, and this will. It's like a fill-in-the-blank morph, but instead of just filling the blank, it has an editor to actually type the notes. You can transcribe them in the language inspired by KeyKit, which is used to represent musical phrase, or graph such a sentence. You can tweak, you can go from one way to the other. And accepting, you get the, so if I say this, I do an exploit. And I accept. I have the result here with the notes. Yeah. The notes have a pitch, have a mode, a volume, a channel. I have the whole structure I just entered. And it's full feature. So for example, this is a quarter note, but with the mouse wheel, I can change the length and input some over length. And there is, in fact, no, not here. Here, all the key bindings that allows me to it's a full feature stuff. It's really comprehensive. So this is one way to use a morph, which is basically at first only this simple rectangle here. This, but in that context, it becomes this thing here. It's just the same, but customized. Another place where it appears in the scratch pads. I have notebooks. Which are another way to input notes very fast. For example, if I do C, arpeggio C minor, I will have the display. If I want to do some algorithmic stuff with it, I can ask this, for example. And the display here, this is it's a plain image, but it has a bunch of buttons on the side here, and I can edit something I just got. So let's say that I want, again, a display which is similar to a traditional display, cheat sheet music. Once I have customized this editor here, I re-click on Disp here, and I just made it a template for display. So now, next time I evaluate this, I will have the template I just asked for. This is an image again, just an image, but it had used the setting I just gave. So if I change the setting to, for example, piano roll, and I reevaluate the scratch pad. No, I forgot to register it. So piano roll, and I register it here, display. And if I reevaluate the scratch pad, I have everything in piano roll. And this kind of scratch pads is what I use for the documentation of muO. For example, here in live documentation, we have cheat sheets, and the string format for musical phrases, which was used in the previous example, is detailed here in a very, very large notebook, which is in fact documentation and interactive documentation. You can change everything here, and you can change the display just as I showed. This explains how to make music from the text format. But I will not dwell on that. And another example of structuring the zoomable fields here is this one, where I have different panes. So this is a completely made up example for this evening. This thing here is again a zoomable field, highly specialized to represent rhythms via it's called the pizza representation of rhythms. Well, here I have a bank of rhythms, and if I present this one, you may learn some this from Led Zeppelin. If I put it here, this is a rhythm that I can get as a box and put here. I will reset this one. So here I'm creating a rhythm or modifying a rhythm. Here I'm getting, so I can again destructure this menu, put this here, get as box the rhythm which is here, drop it in this editor here, which is a drum pattern editor, get as box the drum pattern itself, drop it here. I can make a reset, this one, because here I'm adding rhythm. Here I reset. Okay, get as box. There's nothing here. So I get this one. This is drum pattern editor. From there, I can get a phrase. From there, I can get a MIDI phrase. And here I have the same thing, but just with another display. And so this is another way to set up a workbench. I mean, depending on what you do, you can imagine that you want to play with rhythms and at the same time see their structures in this representation, see how they would appear as plain classical computer representation of a rhythm, see here how they will be translated into MIDI events, and see here even the MIDI events as a musical phrase if for some reason you wanted to do something with that. And everything, of course, here is can be modified. So, for example, if I change the amplitude here of this bass note, when I get it as a box and drop it here, you will have a note, this one here, which has a smaller amplitude than the other ones. And this whole thing is the base for the Bois de Buis standalone application that I made in Squeak, and here, which appears here inside muO, and it's a MIDI sequencer with, again, different zoomable fields, which are a structure for input, for a classical input of something familiar to do a composer of electronic music on computers. This can be done. It looks like something different, but it is in fact a zoomable field, exactly as the ones I showed so far. And we can have also, for example, controllers for any type of continuous effect. This once you have defined things like motif, they appear as little boxes, and you can put these boxes inside the top here and compose your music with them. But I will not describe this here. Just show how this. I'm talking too much. Okay, I think that's good for this one. This was editors as component. And last part is because at the moment I'm kind of done with music on Squeak. I've not done music for a while, but I'm doing games, and I play a lot with geometric stuff. So I wanted to show you also that the generic part, the essence of the zoomable field is to be a plotting system. So, for example, this is a Voronoi tessellation with dots bouncing inside a rectangle, and a real-time computation of the Voronoi boundaries, which is in fact the way to delimit the region made of points which are closer to the central point than to any other point. And this is a zoomable field also. I can make it appear. So this is a specialized zoomable field able to represent geometrical structure, and geometrical. In this context, a geometrical structure is an object which is, in that case, the Voronoi stuff, but can be something else. Here we have the same thing with a fancier representation. But this is a dynamic Voronoi field. Here we have just a painting. So I like it, the fact that you can use the plotting structures the plotting abilities to just make something nice, something pretty. But it can also be used in games.
Yeah, I imagine the whole audience standing up for a standing ovation at this point.
Here I have so this kind of the things. For example, I can print sprites from them. A sprite. It is computing at the moment. Okay, and now I have a sprite. This is an object which can be used in games, which is simply change appearances regularly, but it's generated from this thing. Okay, I found this one. It was nice. This one. And always the same systems. You can destructure I don't know if I have to show everything. You can play with these things. It's fun. It's simple. I made something while playing with these things by making the zoomable thing transparent. In fact, the sprite is a bit hard to delete. Because they are morphs, specific morph. I have to do it this way. Okay. Yeah, by making the framework of the zoomable film disappear, I made something which I consider like in itself a piece of generative art, which is just this thing. So that's how far you can go. And this is also zoomable. The grid could appear actually. Here is the grid.
Well, it was mesmerizing. I've looked at it for a whole hour.
Yeah, it's very nice. It's non-repetitive. It's made so that it will never repeat. Last example, LambdaMessageSend. They're kind of fun. So this is the Hilbert curve. And usually it's presented this way. This is the curve that if you put the iteration infinitely far, is a linear plane curve that will actually fill a square, which is amazing, and make the transition to the 2D black square at infinity. But when you see it this way, you don't necessarily understand how it is generated. And this L system, which is also a geometrical object, so we are still in the representation of geometrical objects here. This one allows us to change the angle, which is normally 90 to generate the Hilbert curve. But since we are interested in the way the Hilbert curve is actually drawn, we can play with the angle and see how, in fact, the thing is built. So I have different wheels for different finesse of this one changes the angle just a little, and you can see it's here. What happens is sometimes the wheel catches the zoom, and sometimes the wheel catches the wheel. Okay, so this is to change the angle by some, this by much more, and this by just a little. And these buttons, this is the opportunity for me to show that the way these buttons have been created is not by using the usual the methods that come in Squeak, but methods I added that use lambdas so that everything keeps in sync when we very deep copy the morph. That's important. So for example, this here is the button I used to create the wheel. So we have one button which is linked to an editor, which creates a wheel which is linked to a parameter of the editor. And all of this, when copied, function as expected. So if I take this button here and I put it here, I ask for a wheel, okay, it works. But now, if I duplicate the morph, well, obviously, the wheel here works on that morph. But also, if I make a new wheel from this button, it will also be the wheel for that morph and not for this one. This is not something you would get out of the box with Squeak. Lots of work has been put in order to get this kind of very deep copyable buttons.
Right. So you finally improved on a little bit of Sketchpad from 1963.
Good. This one is fun. It's Penrose tiling, which is a quasi-periodic tiling actually generated as a LambdaMessageSend system. So I think I'm going in the nerdy side here, but it's kind of amazing, especially when you destructure it and see how the thing actually exists, because there is no way to understand how a quasi-periodic tiling can be emergent from this. It's just amazing. Okay. Yeah, well, fine. This is different generations of the LambdaMessageSend system. So, okay, I think I made it. And it was a bit messy. I'm not very happy with the way I talked. I'm a bit nervous, but that's it. I think I showed everything I had to show for this evening.
Bravo.
Marvelous.
Or should I say da capo, da capo?
Fascinating, yeah.
But a few people wondered the sound visual of the visualizations and the parameter editors. Is there a sound, or are you just making waveforms?
The sound in the here, this one, yes,
Yeah,
there's sound. Yeah. The sound we heard it actually. The sound is still available here in the music part. I can play it. And in fact,
I think Zoom's not broadcasting. I think there's another option you have to set to get the sound. Yeah.
Okay. You don't have sound.
Yeah, it was been silent all throughout the presentation.
Yeah, I didn't make much sound except with my mouth, but twice I played some sound. Okay, so I didn't realize where is it?
You have to go. You have to go back to screen share. You have to unscreen share, and then
okay.
Could you just sing it instead?
No, I can't. Yes, so
and then there should be an option for audio with.
Audio with. No idea where this is. I don't know.
When was the last time any of us had a sight reading quiz?
You may need to go to Zoom preferences.
Well, if
audio, and then let it see play your system sound.
I mean, if you go to share screen at the bottom of select the window, you should get optimized for video and share sound, and it's clicking those two.
Optimized for video, partial. Okay, share sound. I get it.
Yeah, those two.
Yeah, that's it. So let's try.
Actually, could I put in one other special request, which is that I totally sympathize that you don't want. Okay, if we promise not to make any musical judgments at all, and we wouldn't, is there any chance you could switch on the audio for the projection thing?
Yeah.
We treat it just as sonification.
Yeah.
So that we understand all the relationships.
Okay. So this is the sound, by the way. So nothing fancy at all. But I can show you. I will do just as you ask, but I will also show you from a function editor, which I have here. Let's move this out of the way. In the function editor, there is a small library of functions, and there is a sound part, which just sound as equation. So we can play it. So this is will last for, let's say, 0.6 seconds. Okay. Now 3 seconds. Oh, yes, 3 seconds.
Did we just see interference patterns or harmonics?
I have no idea because yeah, it's a kind of ugly impact. I think I found this in Mathematica or something like that, or in Wolfram Alpha. It's a sound wave which is just a function, so it has harmonics and stuff, but it has not been generated in the usual way for synthesis. So now for the projection thing here, okay. So let's see if I play this. So
how do you call the star shape, which is now not a star but more a circle?
Which one?
Yeah, how what is the name of that particular?
No idea.
I first thought of Kvyat star, but it's not a Kvyat star. It was star shaped, and you said all the points would have a bump, but now it's no longer a star. So now it's more of a striped spiral.
I'm a bit struggling here to.
That's why I keep asking. Yeah, what is the name?
So
it should get a new name. It's a distinct category.
I'm just tuning phrasing tune model. The thing it doesn't want to play because I think I did not tune. Okay. He was complaining that the notes were out of tune, and to generate a MIDI output stream, you need the notes that are tuned. Otherwise, it's a bit complex. Microtonality with MIDI is tricky, and I can do it, but not in 5 minutes like that. So we just tune here. Okay. So okay. So this one here. Let's see. So yeah, we can play it, I guess. I will put a cursor so you can see what's happening. So if I take this one, yeah, oh, okay. Well, I can stretch it.
But I now understand that you can't do that live. Change the circle.
This one is here. So I don't know. It takes a long time when I compose music. It takes a very long time to set up geometrical structures that can are really interesting to make sound. And it's part of the design of the piece actually. So this is really like playing the piano by just hitting at random the touches. It's not at all the way I proceed when I do music. Because this particular.
Yeah, well, I imagine that you would interactively move around in a circle and find an emphasis while hearing the sound, so that you actually search for your sound. But you're more predicting it, and then you play the sound.
In fact, I will stop this, but I will share another screen because I anticipated that maybe I would show you the actual image I used to compose a piece to show you what it looks like. So this one here. Okay, let me share this a new screen. Here. That's what it looks like. Where I work. that's my stuff. So this here is a piece of music, and it's made of 1, 2, 3, 4, 5, 6, 7, 8, 9,
Wow.
9, 10 parts, which are each taken from the mess in the background is the test, everything I tried. See how it goes. So for example, if I take this box here. This little box represents a score editor, which is here. And within that score editor, so you have a drum track, and the drum track is generated as this projector composer, which is the kind of thing we just saw. And these are the controls. And here I can show you also how you can play with. I found that so there is only 2 notes. The projector is this stuff here, and I played with these parameters here, and some parameters, because the dots, the points here, they are actually sliders. They can be inside the main projector field, but if the scale is too different, if they have to go too far away, or if they are too sensitive, I can move them into another here, another zoomable field, which is simply the background for the sliders, so that I can stretch. That's kind of, I don't know if it's clear. Oh, there was another one here. Okay. So all this thing here, everything here changes one aspect of the music. For this simple box, which is not even used in that piece, this one. And if we look at, for example, at this thing here, what is it? Okay, this is something else. So this has 2 generators.
The smaller representations are not projects. They're minimized icons of the larger screens.
Yeah, they're actually not only icons, they are boxes, which means they behave. So this, oh, you can see, there are many things here.
You mean they update live? They're not stale?
Yeah, they're live. Yeah. They're completely live. When they're copied, they allow me to make a copy of all part of the composition, changing on the fly, slightly variation, and connect them. And the connectors that are here are a temporal connector. This connector here means that this piece of music will play right after this one. And if I use this kind of box in the middle, that's a mess. This one is really a mess, because that's an actual thing I've been using to make music. And in fact, one of the main thing when I compose is to completely forget about I just think about the music itself. So the background, the Squeak desktop becomes a mess of stuff that it's like I'm in my kitchen and cutting vegetables everywhere, and I don't clean up until the end.
Basically, it is a representation of your visual of your.
That's my brain on music.
Yeah, but that's why it's so marvelous. I mean, it's a reflection of what's actually in your mental space.
Yeah. That's
communicating with aliens, as Leksleider said. But
this is a cyborg tool. This is my brain extension, right?
An intellectual amplifier for humans pervasively into.
And I think Morphic is marvelous for that, because it allows this kind of. So I like visualizing stuff. So of course it's maybe more fitted to someone who likes 2-dimensional displays. But when you have a feeling with this kind of representation, Morphic allows to make very interactive things very deeply.
David, would you ever have imagined when you first worked with Morphic?
Oh my. I really would love Randy Smith to see this. It's very cool. And I would love to get more whys as opposed to what's about this. Steph, you've clearly put a ton of work into it. How long have you been working on this?
It's 20 years, 20 years. Because
wow.
this, in fact, is my, how should you say? This is my
magnum opus?
no, my quest to understand how you do music, because I love music, but I don't have a formal education, so I'm self-taught, and I build the structures. I used also the fact that I implemented this, and also things that I didn't show you, like the modelization of musical structures. I use that to teach myself what music is, in fact. So
you see, this is exactly the kind of why that fascinates me. So you started out wanting to understand music.
Yeah.
And was this an interactive process between building tools and understanding music?
Yeah.
Are you saying that there was an interplay there? And that's fascinating.
Yeah, completely, yes. And I think I have a computer model of, for example, of harmony that does not exist in other musical systems. Because
that would be. Go ahead.
I'm a physicist by education, kind of math person also. So I created mathematical modelization, because the music is very, very, well, it's amazing with the relationship between mathematics and music, and it's completely obfuscated in the way music is taught, because it's very complex also. And
there's a. I'm sorry, I'm going to interrupt you anyway.
No,
pardon me for being rude.
Fine.
Really, really fascinating, at least to me, talk you could give. If you could remember your journey and what you learned about music when, and the tool it inspired you to build, and then what you learned later that changed your mind to build something different. There's that, understanding you're a physicist learning about music without the constraints of the standard music theory culture, and then the interaction with tools and building. That's a talk that would just be incredible, with audio examples throughout, of course.
Yeah.
Yes, I agree, David, and I wrote in the chat. I'm quite sure that Peter Gabriel, for example, who would also want to hear that talk, but would say, "Oh, please, what can I do to make that talk happen?" He would invite you and then make a grand documentary about it, or probably just go jam with you immediately, because he would also have, how could a physicist visualize things that I have been trying to visualize for all of his life, and he failed completely because he's not a physicist, he's actually just a musician. But the point is, you're onto something way more interesting than just the editors. It's
precisely, and mind you, Steph, putting together such a talk is serious work, because you have to think carefully about the steps and what to show. And it's not anything to be approached lightly. And you have to give a practice talk to your friends and take 3 hours of feedback and redo it and everything. Just as if you were giving a physics talk to a college. Anyway, go ahead, Steph. I'm sorry.
Yeah,
but imagine that somebody, there's 100 books written about Bach and Beethoven, how they were thinking while they were composing, for example, Furelise. By making such a talk, you're making something that in 2,000 years people would still want to see and follow and learn about.
About just this very talk I just made, was it clear? Was it okay? Structured correctly?
If you're asking me, I got confused in several parts of it, and it went into too much maybe I have attention deficit disorder or something, but there are places where it went into too much detail and I just kind of tuned out, honestly. I didn't like when you introduced the star, I had no idea why. What's this thing for? Is it just a pretty thing? And so I think one of the keys is to have the whys and to make every, there's a fractal structure of tension and release in a good talk that you need to attend to, which also contributes to clarity, holding the audience's attention via suspense. But feel free to contact me offline. I'm very happy to talk about this and reach out. I guess since this is recorded, I'm not going to recite my email address.
Okay, but this
you can probably get it through somebody. Anyway, I'll let Merrick talk now.
No, David, I just wanted to reinforce you and say, but why do it offline? I mean, I would be fascinated to hear that talk, that discussion too, because that's what these software things get us to. I'm also interested in the why, but also interested in your why, because you created some of the tools that he's now used 20 years to get in his journey of thinking and involvement, etc. But you started it, so the interaction between you two is even more interesting than either.
Oh, well, thank you, Merrick. And some of my talks are online, and some of the papers that Randy and I wrote, well, they're probably all, programming as an experience, and the Hoppel paper, History of Programming Languages. So, Steph, in case you're at all tempted to take talk advice from me, before you do, you ought to look at one of my talks online and see if you like my style, because you might or might not. So.
Yeah, well, I don't know if I can learn your style too, but this one is my first Zoom ever talk anyway. So, wow.
Now that you invited that, David, your style is unique. It's not at all like LNK's, but they're more riveting than LNK's, and that's saying something. I've seen them all many times over. You changed my life that way with these talks.
Oh, well, thank you. Flattery gladly accepted, but I'm honored. I'm truly honored, Merrick.
Yeah, but my 2-hour talk about parallel hardware was all about flattering you. That's why I was a little, you didn't see it. You only saw the first 30 minutes. But the point is, yeah, you inspired us to do our life's work.
So someone just asked for music that was made with these tools, and in the image I proposed, there is a link. Actually, all the music I made is online and is free to download. It's all Creative Commons
for you there. There's over 20 questions for you there. Maybe too much for today.
So where did I find? Where did I do I find the questions?
Okay, if you
so the first one, for example, why not one morph with a switch? And is the window itself a morph that could nest?
Which window?
Okay, if you go down to the bottom of the gallery, the screen with everybody's faces on it, you should see a chat icon.
Chat icon, discussion.
And if you
okay, fine. Okay, the drum machine. Oh, okay. Which time we need to miss? How many? The number of line of codes. I have it. I have it in. Let me open another quick image. So I have a question about the number of line of codes, and so muO line of codes 134,000 lines of codes. That's muO.
Actually, may I ask a question that I think picks up on several questions in the chat, if I may? So your system appears to use a whole bunch of composition methods in the sense of object composition, right? In the sense of object composition, it looks like we're using a bunch of different techniques. Now, of course, there's a bunch of good techniques for doing that in Morphic, but in fact, in David's career after Morphic, he went on to do all kinds of systems going into outer space, doing amazing other interesting methods of composition, object composition. So I'm wondering, in your I'm wondering, in your system, did you have to build in any sort of non-obvious?
Yeah. In fact, the talk for this evening is only about this specific zoomable field. It's not about the musical composition methods in muO, because this is just one part of it. There is also the methods which are not especially graphical, and I would need another presentation and another way to structure the matter to present muO in a more in its whole scope. What I wanted to do this evening is to show also to people who are not into music that maybe there are tools inside muO that can be of interest to them, like if they just have to visualize some kind of geometrical data in an interactive way. And about
for example, it should be tied to Mondrian and Roasal, and it should be interacting with the Glamour toolkit. But those are just two things. I can name 50 more. You expanded the whole use of morphs in 3 directions. Dimensional axes. So that will change all the other morphs we've been building to make them much more rich.
And what I'm working at the moment is a game, 2D game, and top-down, where you move some people in a procedurally generated world with autonomous agents, like an adventure game, something like that. And because it's top-down, and because the world is procedural and generated by methods which are linked to this, my goal now, which is something I'm not sure to obtain, but I will try. My goal is to have a generative music for games, having the game world generate itself via the projective stuff.
So that's the opposite of the iTunes visualizer style thing. It's now it's a musicalizer.
It's I don't know. It's I will tell when I do it what it is exactly.
What is your physics background?
Just don't put any machine learning in. That would be.
Oh no! This is awful. Excuse me, David.
What is your physics background? I'm curious.
Oh, it's just no basics physics. I went up to just before the PhD, but I did not do a PhD.
And what part of physics? Theoretical, experimental, quantum,
theoretical. Yeah, I was.
Oh, any particular area? Go ahead, please.
Well, at the moment, I'm interested in quantum physics, but just for a hobby. And at the time I was doing my studies, it was. In fact, I was more curious of different things, and I went to crystallography, but I didn't work on physics. I'm not a physicist. I'm not a working physicist. It's just my education. What I did after was photography and stuff like that.
I think there are interesting connections between a person's particular interests and the style of art or creation or engineering. So thank you very much.
And I was talking about the metrics, so I had this line of codes, and if you're interested, the classes, there are 1,000 classes in muO, and 25,000 methods. And that's just muO, but muO has subparts like graphs. Graphs have which is functional talk as 600. Well, I don't know if we had everything together. We have a figure somewhere. Yeah, well, that's thousands of classes.
I'll just throw one more piece. Randy also has a background in quantum physics, theoretical quantum physics. And so it's very interesting and possibly not coincidental, the great Morphic work you've done, building on the great Morphic work he did. Very interesting. Thank you.
Considering how many physicists who don't practice physics in their career that are part of Squeak and have been doing major advances, I would say that statistically alone, that is the case.
Yeah, I always say a great mind is a terrible thing to waste when I think of physicists going into programming.
Yeah.
That's a joke.
Yep.
Well, the physicists are known to waste a lot of their brain power at the moment. Yes, I don't know. So I'm just browsing the questions. Mechanism. Danny Oppenheim slappability architecture. Yeah, exactly. This Danny Oppenheim, I discovered his work just last year, I think, and I realized it has exactly the same mindset as I have. I was struck by the fact that we saw things the same way. So I'm not inspired by what he did, but I realized that's the same.
Well, that's really super interesting, because I mean, when Danny did that, which is fantastic work, you know, he used a pretty simple implementation, you know, which was to do with just ordinary inheritance, but used in a clever way. But more recently, that work's been expanded in very interesting ways using stateful traits and talents. And I wonder if your architecture may have gone off in any of those interesting directions beyond, like, well, sorry, it's to do with the composition question again, stuff which shows up absolutely in David's stuff, you know, in some of those later amazing systems. Yeah.
So about the interaction between muO and Siren, we have Stephen Pope here. So hi. No,
I was the guy who said bravo, Stéphane.
Oh, thank you. Thanks. So no, I don't have. I think we have different ways to see music, and also I had to start from scratch just to understand what I'm talking about 20 years ago, and I had to make things really from ground zero. So,
but Steph, you did see Stephen Pope's work 20 years ago.
Yeah. I made a technological survey of all systems to make music with computers. I had at first. I did not have the idea to spend 20 years building a system to make music. If I could have made music in two months, it would have been better. but
now we have to wait 20 years for Stephen Pope's reaction to your work.
Well, he's back. He's back to Squeak. It seems we see some activity from
just the last couple of weeks.
Yeah.
Actually, I've got a horrible low-level question which you should just refuse to answer and tell me to shut up, which is I'm interested in how you get new MIDI out of the virtual machine and your audio out of the virtual machine.
Sorry, the question is about the audio.
But it's a terrible question. Terrible question.
Tell me.
How are you getting your MIDI?
We had a plugin
out of the virtual machine. Which version of Squeak?
I output a MIDI stream, a pure MIDI stream using the MIDI abilities of Squeak itself.
Which version of Squeak?
Squeak's. I started with Squeak.
This version 2 we have.
Squeak always had a MIDI port.
Yeah, but it doesn't have on version 5 and version 6. It's been basically that no longer works.
Yes, it works, but maybe not on all systems. Maybe in Linux there are some problems. I think I saw problems in Linux sometimes, but I'm on Windows, and on Windows it has always worked. You're on Windows.
Oh, okay, you're on Windows. All right. Okay.
Yeah, it has always worked.
Okay.
So I had some problems of latencies at the beginning, but now the VM is much better, and also. when I output the stream, I get rid of everything that is moving in the image. Possibly, I even dump everything in the image and just keep the object emitting the stream. And I have generated pieces of 16, maybe 20 minutes long without any problem of noticeable problem of delay. And then I feed this stream to VST virtual instruments, and that's it. And I record them live. So there are questions about pure data with pure data. The links that are between boxes in my system are not the same. They have not the same logical function as the links in pure data. In pure data, it's sound. But I know I didn't use pure data ever. I used Csound. I did some pieces in Csound. And actually, I did an Emacs mode for writing Csound scores and orchestra a long time ago. So I don't know how it would mix with pure data. Pure data is a synthesizer. Squeak, I didn't. Well, that's another amazing field of research to do sound synthesis, and I didn't go this way in Squeak. So have I missed a question? I don't know. I think I answered.
Yeah, a few, but you're doing great.
Can we hear the drum machine? I don't know. It's from Stewart. I don't know what the drum machine was.
Comment: 130,000 Klog lines, 1,000 lines of code.
Yeah.
Would you have been helped by a DSL we wrote on top of a matter, so you could express music? Or
no. I made the DSL. I have my own DSLs in the system.
Oh, there are. Okay.
Yeah, maybe several ones actually. In fact, muO can read EAS parser that I wrote for ABC format, for example. You can write Csound code, and I based the representation for melodic lines from KeyKit format, because before muO on Squeak, I made the first version of the projection system on KeyKit. That's from Tim Thompson, and it's a very nice MIDI system. And I have DSL for many stuff. Actually, every time I have a specific class of problems that appears, I first create the ground state for discussion about this affair. So I always go abstract first, and then that's why it takes me 20 years to make a piece of music, because someone normal takes a guitar and makes the sound and play the music, but I first want to understand why the guitar has the shape of the guitar, and then I build the guitar, and 20 years later I still don't know how to play the guitar.
So one observation. So we've had, I mean, this is very rich and inspiring work, and we've already spoken about several lenses that could be put on this to extract all kinds of stuff from it. But one additional lens is it'd be well worth going through this, indeed, as somebody's mentioned in the comments, from a sort of Brett Victorish point of view, to think of human-computer interaction and, you know, visualization, etc. Things that, you know, I mean, some of them have stuff in common with other things, but some of them seem a bit unique and interesting simply from an HCI point of view. And that would be one interesting thing to just go through and do a kind of audit and see what there is to pull out there.
I just sent this image to Brett Victor, and he immediately responded by saying, I'm going to clear my schedule. Spend a couple of hours on it. So he's reading your feedback, Steph.
Yeah, the thing is, and this has been a problem for the whole 20 years I spent on this thing, is that documentation really never catched the development, because every time I wrote one line of documentation, it brought me one bug, one problem to fix. So I went back to fix it, and the documentation was immediately obsolete. So I started again, and then another problem. So I fixed the problem, and eventually I found that for myself, the structuration of the code within Squeak, and that in itself is amazing, is clear enough for the system itself to act as its own documentation for me, of course, just for me. But this makes it very difficult to know how to introduce this to someone else, because like, I just have to appear out of the blue and say, hello, I have 100,000 lines of codes that do this, and no real way to help you dig it. So that's
I think the examples and just the browsability of Smalltalk code, you can understand a lot more than you give people credit for. Actually, I think it's I'm sure it's written with love and compatible with all the examples in Smalltalk. So I would imagine that many of us with a few prods could begin to immerse ourselves and pick a little area and understand it.
Hopefully, yes.
I mean, I just wish more things worked this way. I mean, when you were, some of the tools that you were creating and assembling, there's not enough of that kind of stuff, is there? It's like, it's so frustrating, I'm looking at things around my house. I'm like, oh God, if only I could play with them and change the way they worked and do what you've just done with your interpretation of music. I think it's brilliant. It's inspiring.
Steph, you wrote an average of 20 lines of your code a day in the last 20 years. Did you write them in bursts, or is it just evening work, or are you?
No, I do not work. I have no
play. Okay.
And I'm very poor. I have no money. No, I'm joking. I'm married, so my wife provides, but I'm not providing anything. I'm a father at home. So I did that because I had to take care of small children, and so when they did not need me, I did that. I had plenty of free time.
Right. Then you're lucky. I'm much poorer than you for the same reason. So. But it's marvelous work. But so you couldn't write it in big bursts of one day. You wrote it gradually over time.
Yeah, I don't know.
And then all the days in between, you play around with it in your head in the shower while changing the diaper.
Really, I have no idea. Also, there was a phase of building. Not knowing if it would lead to some place, and when I started, I could say the music I started to do, which kind of I found was kind of okay, was from 2015, and at this time the system was almost complete. So for the last maybe 8 years, I've just added a few things there and there and made music. So there was really 2 times: the time of elaboration of the conceptual structure of the system, and then the time of actually using it to make music. This another rhythm, and because it works, it's the way I work. It takes a very long time to set up the system, but when I do a piece of music, and if you listen to the different pieces I've made, some are quite long, some are complex, lots of notes, lots of structure, harmonic structures, rhythmic structures. Sometimes I made this piece of music in 3 hours, or 2 hours, or 1 afternoon, or 3 days. But based on 15 years of putting together the tools so that when I make a piece of music, I am in the same mind state from the beginning to the end. It's in the flow, and if the flow is interrupted, then I have to stop doing this piece of music and I program. So it's kind of a cyborg cocoon to allow my mind to really be able to express music. And in that sense, it's an instrument, in fact. It's an instrument of composition. instead of being an instrument of to generate sound, it's an instrument to generate compositions. And if I in the mood, I can play that instrument and I compose on the fly, and that's the fun with it.
Mm-hmm. If David Unger will ever forgive me, David, if a student would come to you with this work, would you sign his PhD, this type of PhD?
It depends. It's complicated. It has to, it's wonderful stuff. There has to be a book. There has to be a lot of explanation in the book. There has to be references of all the previous work and all of that. There has to be an original idea that you can state. Well, some PhDs are survey PhDs, so it's complicated. But you know, I'm sure there's a
novelty.
PhD. There's a PhD hiding in there somewhere, for sure.
Right.
And I'm just sorry we didn't get to hear some of the music you used this to compose.
Yeah, I can play, but you have everything on internet. I mean, if you want, I can play you a piece of music, but I think it would be a waste of our time together because you can do that. It's all online. It's all Creative Commons.
Yeah,
is the music just the sound, or will it then visualize all the?
No, it's just the sound, just music, playing music.
Sorry to interrupt, but since you know, Stéphane has already mentioned that you know, the focus of the desktop was just on some of the components, and there will be a lot more to cover about the whole system. I'm going to cheekily propose to Stéphane if he would like to come back later in the year and can organize something where there's going to be a lot more of his music being played.
But then what would be the subject?
We can discuss it.
Interaction with Brad Victor, maybe interaction with a few musicians who have seen the work and have 1,000 questions by then.
Okay, well, I'm very happy to share whatever I can share, of course.
We're quite happy to have you again. This has been quite an interesting presentation. And if you notice, we said it would be 45 minutes, but it's been a lot longer than that. Which means that people...
Mine was 4 hours. I'm happy to continue. We haven't even exhausted half of the questions on the chat, let alone what other marvels are hidden in this work.
Well, thank you for
again, Steph. I'll repeat my offer. If you want any David Unger style coaching on any kind of talk, please reach out to me.
Yeah, sure. I take care to watch your talks and get in touch. Yes.
Okay. Thanks.
Yeah. Anyway, it will not be immediately for the next video, so we have plenty of time to see that, and I have to practice because I'm ready to. I mean, obviously I know what I'm talking about, but I discovered tonight that it's kind of difficult to handle to have such an audience. I know I'm impressed by you people, so I'm a bit not too comfortable. Maybe
as you can see from the comments, you know, the thing is reciprocal. Plenty of people have been impressed and inspired.
Well, thank you.